All right, let's tackle one of the biggest, strangest questions out there. What is time? I mean, we live in it, we feel it every single second of our lives, but the closer you look, the weirder it gets. It rules everything we do, but it might not be what we think it is at all. So let's dive in. To get us started, here's a little puzzle for you. Imagine you have a perfect, super accurate atomic clock strapped to your wrist. Now, picture an identical clock, just zipping around the Earth on a GPS satellite. Why on earth would those two perfect clocks start to disagree? It just seems impossible, right? And here's the kicker. They do disagree on how much time has passed. And get this, they are both 100% correct. Now that's not a riddle, it's a fundamental fact about how our universe works. And to understand it, we're going to have to throw our everyday intuition about time right out the window. So how in the world did we get to such a bizarre conclusion? Well, to figure out why those clocks don't tick in sync, we need to take a quick journey through history to see how our whole idea of time got completely turned on its head. This debate, believe it or not, is ancient. Way back, over 2,000 years ago, you had the Greek philosopher Heraclitus. He argued that time is this constant, unstoppable flow, kind of like a river. But then you had his contemporary, Parmenides, who had this totally different, radical idea. He thought all change, and by extension, time itself, was just an illusion. And that fundamental question, is time real or is it all in our heads, has been bouncing around ever since. For a long, long time, science had a pretty solid answer, and it came from Isaac Newton. He came up with this idea of absolute time, basically a giant invisible clock for the entire cosmos, ticking away at the exact same rate for everyone and everything everywhere. You know what? It feels right, it's intuitive, and it worked perfectly. For a couple of centuries, anyway. Then, a guy named Albert Einstein came along and just shattered Newton's universal clock. He showed us that space and time aren't two different things. Nope. They're actually woven together into this single, four-dimensional fabric he called spacetime. And the craziest part? This fabric isn't stiff. It can be bent, stretched, and warped by gravity and motion. This has two really mind-bending consequences. First, something called time dilation. It means the faster you move through space, the slower you actually move through time compared to someone who's standing still. Second, and this one's even weirder, is the relativity of simultaneity. This means there's no such thing as a universal now. Events that seem to happen at the exact same time for you might happen at different times for someone else. Here's the classic way to think about it. Imagine you're standing on a train platform, and lightning hits both ends of the platform at the exact same time. For you, it's simultaneous. But for a passenger on a super fast train speeding by, the light from the strike up ahead reaches them before the light from the strike behind them. So for them, the strikes were not simultaneous. The wild part? Both of you are right. Your now is personal. Okay, so time is relative. It's personal. But that doesn't explain another huge mystery. Why does it only go in one direction? Right? You can scramble an egg, but you can't unscramble it. Why is time a one-way street? Let's put it another way. Our entire experience of reality is built on this. We have vivid memories of the past, right? But we have absolutely no memories of the future. This feeling, this arrow of time that points from yesterday to tomorrow, is one of the most basic things about our lives. So what causes it? Well, the answer comes from a concept in physics called entropy. Now, in simple terms, entropy is just a measure of disorder or randomness. And one of the most fundamental laws in all of science, the second law of thermodynamics, says that the total entropy, the total disorder, of a closed system like our universe can only go one way, up. Things always tend to go from order to disorder. So think about it like this. Our universe kicked off in this incredibly ordered, low-entropy state. You could imagine it like a perfectly new, unshuffled deck of cards. From that starting point, the second law of thermodynamics takes over and says things have to get messier. And it's this relentless, one-way march from order to disorder that gives time its arrow. That's what creates our experience of past, present, and future. So, we've seen that time is relative and it has a built-in direction. But this brings us all the way back to that ancient question. Is time a real fundamental part of the universe? Or is it just something our minds create? Let's take a look at the cutting edge of this debate. Philosophers basically have a few different models on the table. There's presentism, which says only the now is real. That kind of matches how we feel, right? But then there's eternalism, often called the block universe. This idea suggests that the past, present, and future all exist, all at once, just like different places on a map. And that idea actually fits really well with Einstein's spacetime. And then there's the growing block theory, sort of a middle ground where the past is real but the future hasn't been written yet. But it gets even stranger. When physicists try to mesh up Einstein's theories with the bizarre world of quantum mechanics, something incredible happens. Some of their most basic equations for how the universe works, well, they just don't have a variable for time in them at all. This has led to this mind-blowing idea that time isn't fundamental. It might be an emergent property, something that arises from a deeper, timeless reality, sort of like how the feeling of hot emerges from the jiggling of countless tiny atoms. And here's the final twist, and it's happening right inside your head. That smooth, continuous feeling of time flowing by right now, yeah, that's a story your brain is telling itself. Neuroscientists have shown that our brain is constantly stitching together little bits of information from our senses to create the seamless experience of the present moment. The flow of time we feel is actually a masterpiece of biological engineering. Now, I know this all sounds incredibly abstract, right? But these strange properties of time aren't just for theoretical physicists to worry about. They have very real, very tangible effects on the technology and the world all around us every single day. Let's go all the way back to our GPS satellite. Its clock is actually running a tiny bit faster than ours because it's in weaker gravity. But it's also running a tiny bit slower because it's moving so darn fast. The engineers have to constantly correct for both of Einstein's relativity theories. If they didn't, the GPS on your phone would be off by miles every single day. And we can see this stuff happening in nature too. There are these tiny particles called muons created high up in the atmosphere. They have a super short lifespan and should decay long before they ever reach the ground. But because they're traveling at nearly the speed of light, their internal clocks slow way down because of time dilation. They live longer from our point of view, and we can actually detect them right here on the surface. It's relativity in action. And what about the arrow of time? You don't need a fancy lab for that. Your kitchen is a perfect physics lab. Every time you watch an ice cube melt in a glass, or cream mix into your coffee, or an egg scramble in a pan, you are literally watching the second law of thermodynamics play out. You are seeing a direct, physical example of time's one-way street. So where does all this leave us? Time is stretchy, it's personal, and it has a clear direction that's driven by the universe getting messier. It's real enough that we have to account for its weirdness just to navigate around town. And yet, that smooth, flowing river of time that we all feel so deeply is an illusion, a story constructed by our own brains. So I'll leave you with this. What is it really?